Hey AP Stats, back at you with the second video for week one. This one is about DUFS and finding the least squares regression line from computer output. So, DUFS, what does that stand for? Why do we use it? Let's talk about that. We use DUFS anytime we are given a scatter plot. So, if we need to describe a scatter plot, use DUFS. From the last video, if they're asking you to describe a distribution, that's SOX. So describing one distribution is one variable, but when we talk about scatter plots, that's two variables, the x and the y. Direction, okay, so you're either going to have positive, negative, or maybe there's no direction at all. But my hunch is if they give you a scatter plot, it's probably going to be positive or negative, usually. Unusual features, so that's outliers, possible gaps, maybe clusters all around one area, similar to the outliers / unusual features of SOX. F is for form, it's going to be linear or it's going to be nonlinear. If it's nonlinear, you have other options like exponential, quadratic, whatever. In AP Stats, we usually just stick with saying, hey, it's nonlinear or linear. And then strength is the S. And so for strength, weak, strong, moderate. What I like you guys to do is use words like fairly, moderately. So fairly strong, moderately strong, just to kind of make our words a little bit more safer. Okay, that's DUFS. Least squares regression line, LSRL from computer output. That example is down below. Oh, it's right here. But so stay tuned for that. Let's do number one. This is actually a throwback question from your 3.1 quiz. So the scatter plot below shows the fuel efficiency in miles per gallon and weight in pounds of 20 cars. The correlation coefficient is R equals negative 0.6. Oh, how nice of them to give that to us. That will help us look at the strength. Based on the scatter plot and correlation coefficient, describe the relationship between the two variables. So ding, 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 they said describe the relationship between the two variables. There's a relationship when there's two variables. So I'm just peeking down here. We have car weight on the x-axis and we have fuel efficiency on the y-axis. So if I have to describe this relationship, I know I'm going to have to use DUFS, and I like to just write it out for myself up here before I write the full sentence down here. We need DUFS, and remember what we always need, context. This was the same for SOX. To get that full credit, you have to mention the context. Okay, direction. Well, I can tell from the scatter plot, this is going down, it's negative. The correlation is also negative, so those clue me into negative. Unusual features, looks like an outlier right there. So remember, if you tell me there's an outlier, I can't really give you credit unless you give me some more information. So I'm actually going to guesstimate where this is. Let's say that's 3,000, 49. Okay, so there's an outlier. Form. This is going to be linear. I don't see any weird curves or parabolas there. The dots all follow a general pattern of a line. And then the strength. Well, they gave me the correlation, so I'm going to go off of that. Negative 0.6. That's kind of like close to 0.5. And when anything is close to 0.5, I usually go with a moderate relationship. It's not really weak. It's not really strong. It's just like fairly moderate. Look at that, using both of the words. Okay, and the relationship is between the two variables. What are the two variables? It's car weight and fuel efficiency. So I'm going to write a sentence now and making sure I have context and I have DUFS. And honestly, you don't have to do it my way. I'm just weird and I like things to sound nice. So I usually just think about like, oh, what order should I put DUFS in to make this sound really nice? And I usually come up with something like this. So there is a fairly moderate, okay, I got the strength there, fairly moderate, negative linear relationship. Notice I didn't do the outlier yet. Between, okay, I need my context here. Car weight down here on the x-axis, car weight, and what was the y? It was fuel efficiency and fuel efficiency. That sounds nice. And there's an outlier, so I'll say with possible. It's probably an outlier, but I didn't do the formula, so I'm just going to say a possible outlier at approximately. It's always good to be safe with that word approximately. Done. Okay, so just going to highlight what we have here. So we have direction, unusual features, form, and strength. Cool. So I usually get a few questions about, well, when we're talking about correlation, like what is strong, what is weak, what is moderate? There is no hard and fast rule here. Honestly, like if you're kind of close, I think it's fine. I'm just going to give you a guide for what like I usually think, but just because I say this doesn't mean that someone else might think that what I call moderate is like slightly weak or something. So just use this as a guide. Okay. I would say like anything kind of like in this area-ish, like up to 0.3839 maybe, I'll typically call that fairly weak. But as I mentioned earlier, as we get closer to that 0.5, like the midway mark, like even up to like maybe like 0.69, I call that fairly moderate. And then starting with like 0.7 and up, I will call that fairly strong. And notice that I am so, I don't know what the word is. Like I'm being really careful by using this word fairly. I'm being safe because I never want to say something is perfectly strong or perfectly weak, because is it? It's better to say fairly, in the same way that I never say anything is normal. Nothing is normal in stats. Approximately normal? Yes. Okay, so hopefully that helps with strength and correlation. Remember, R is correlation. And then if you guys remember what R squared is, that's variability. Yeah. Cool. So when we interpret R squared, if you remember, like, I'm trying to think off the top of my head here, but I can't remember. So I'm peeking at my notes here. So when you interpret R squared, let me see. That is the coefficient of determination. Coefficient of determination. You get the point. And it tells us about what percentage of the variability in the y context is accounted for by the least squares regression line. The trick here that I usually see in multiple choice is that you have a negative slope like that, and your R squared is always positive. So for instance, this R squared would be negative 0.6 squared, which is 0.36. And so they give you R squared and they're like, what's the correlation? And then students will usually say, oh, the correlation is 0.6 because that's the square root of 0.36. But we forget that. I forget. Honestly, I do this all the time. I forget that the slope was negative. So R is actually negative 0.6 if you were working backwards like that. Okay, this went on way too long. Sorry. Okay, next example. The one you were waiting for. Least squares regression line from a computer output. This is an actual free response question from 2002, number 4. So I highly, highly encourage you, Google this, look at it, see how the other parts of the question are. If you're curious, see how they scored it. But I just want to talk about part A today, which is, let's read it. What is the equation of the least squares regression line that describes the relationship between operating costs per hour and number of passenger seats in the plane? Define any variables used in this equation. Honestly, when I first did this question, I didn't even read the top part, which is terrible. Obviously, I want you to read the top part if you were doing this full question, but we're just doing A. So I just need to know the equation of the line and the two variables. And if they give me the scatter plot, I usually cheat and I just go there and I see, okay, well, this is the X variable, number of passenger seats. Okay, this is the Y, operating cost per hour. If they don't give you a scatter plot, obviously I want you to go back into the problem and like read it and get the context from the problem. Okay, your least squares regression line is going to be Y hat equals A plus BX. Now, you don't have to write that. I'm just writing it to kind of review here. So if you remember when we did least squares regression in our calculator, you go to stat, you go to calc, and there's actually 2 linear regression options. I tell you, please do number 8, linreg, aka linear regression, because in stats, we like the y-intercept to be first. The y-intercept being A, and the slope being the B next to the x. Whatever is next to the x is the slope. Woo, algebra 1. Okay, and we always have y hat, because that means predicted y, because this line is predicted, it's not the actual point. So we have to write the equation, aka plug in the numbers for A and B. And then we also have to define variables. So I'll tell you guys, okay, I want you to write the equation twice. One time with numbers, one time with words. Okay, here's where you go. There's a lot of stuff going on over here. Honestly, what really matters is look for the word constant and then this coefficient. This is going to be this column is the most important to me. So the constant, aka the number by itself, is the y-intercept. So that's 1136. So A is 1136. Okay, and then coefficient with the seats or whatever variable is here, but in this case seats is x. That's your slope, aka seats is x, x is slope, aka 14. All right, hopefully that was helpful. Sorry. Okay, that is my equation without the words. So I haven't defined any variables. Let's define the variables. What was y? Oh, I said y was operating cost per hour. Okay, so I'll just write operating cost per hour. And remember, this is predicted, so throw that hat on top there. 1136 plus 14.673. What was the x? X was the, oh, right here, number of passenger seats. Okay. That's it. Woo! So this was a nice question. I've looked at so many other examples of computer output from the AP exam, and a lot of them, they don't even ask for the equation. You need the equation for the stuff they ask you next, like interpret the slope, interpret the y-intercept, but they don't ask for the equation. And I get sad because I'm like, well, all my students know how to do it, but they don't even want this equation. Okay. Bonus, super important bonus. Sorry guys, I was thirsty. I want to give you some interpretations. This is review. Bonus. Interpretations. Just in case, because you never know what you got to interpret on an AP Stats exam. Let's just do 2. The 2 most important ones in my mind. The y-intercept and the slope. Sorry, dying. Okay, what was the y-intercept again? It was this number. So I'll just write it here to remind myself, and the slope was this number. All right. Y-intercept is, when you're thinking algebra, this y-intercept, it's where x equals 0. So I need to talk about the x equals 0 context. Well, the x context is number of passenger seats. So when there are 0 passenger seats, aka when there are no passenger seats. If you say 0, that's fine too. Okay, now the word that is so important, the predicted y context. So the y context is operating cost per hour. So the predicted operating cost per hour is 1136. Makes sense, right? If you plugged in 0 to this equation up here, this would cancel out and you would be left with that. So when there is 0 seats, you still have an operating cost to run this plane, which is $1,000. Okay, let's do the slope. So that was the y-intercept. Slope time. Okay, so slope if you think about it from an algebra perspective, as the x increases by 1, like slope is rise over run, right? Okay, so I teach algebra too, I swear. Okay, the slope rises by 1, the y runs by how much? Did I do that right? I have no idea. Okay, please ignore me, team. I have no idea, but rise over run, okay? So it's really late. I'm so sorry. With each additional seat, so with each additional, passenger seat, like how much does the y increase by? Okay, I did it. Let's see, the predicted, there's that word again. It's almost as important as approximately, the word approximately. Actually, maybe it is as important. The predicted operating cost, so this is the y context, operating cost, increases. Now, I'm using this word increases because this slope is positive. If the slope was negative 14.6, then I would say decreases. Increases by the slope, which is 14.67. We're talking about money, so I'll just cut off that 3 there. Okay, there's your prediction. Interpretations right there. Okay. Bye.